Assalamualaikum, welcome to our video. Today we would like to share with you guys our solution for question 4. And without further ado, we will continue with the solution for the question given. And so, the first step we take is to form the system of linear equation. From the question above, we can get 5 linear equation, and from the 5 linear equation, we can form a system of linear equation. The first linear equation we get is x1 plus x2 equal to 20. The next one is x2 plus x3 minus x4 minus x5 equals to negative 10. The third equation is x3 plus x6 equals to 30. The fourth one is x1 plus x4 minus x7 equals to 0. And the last one is x5 plus x6 equals to 35. From these 5 linear equations, we can get a system of linear equation. For step 2, we need to solve the system. And our group have decided to use the Gaussian elimination method. And the first step for this method is we need to create or form an augmented matrix from the system given. From the augmented matrix that we get, we need to transform it into row echelon form. From the augmented matrix, we can see that the first non-zero entry is 1. So this is the leading one for the first row. And then the next step, we need to make sure that everything below the leading one is 0. And from this matrix, we can see that there are number 1 at row 4. So we need to do elementary row operation into the matrix to make it into 0. And so the formula is negative row 1 plus row 4 placed into row 4. And from that operation, we get this matrix. Now we proceed to second row. We will repeat the process that we have done in step 2 for the second row. The first non-zero entry in the second row is 1, and this is the leading one for this row. And then we need to zero out everything under the leading one. To do this, we need to use the elementary row operation. To zero out the negative one under the leading one, we need to add R2 with R4 and place it into R4. Next, we will proceed to row 3. We will repeat all the process we have done before for row 3. The first step, the first non-zero entry for row 3 is 1, and this will be the leading one for the third row. Next, we need to zero out everything under the leading one. We will add negative R3 with R4 and place it into R4 to zero out everything under the leading one. Next, we will proceed with row 4. For row 4, the first non-zero entry is negative 1. So, we need to change it into positive 1. To do so, we use elementary row operation. The formula is negative R4 placed into R4. After we get the leading one for row 4, we need to zero out everything under the leading one. To do so, we need to use elementary row operation. We need to add negative R4 with R5 and place it into R5. Next, we will proceed with row 5. Row 5 is the last row in the matrix. So, the first non-zero entry for row 5 is negative 1. So, we need to transform it into positive 1. To do so, we need to do elementary row operation. The formula is we multiply R5 with negative 1 and place it into R5, and then we will get our leading one for row 5. Since there is no element under row 5, we don't need to cross out any number. And finally, we get our row echelon matrix. Next, we need to transform the row echelon matrix into a system of linear equation to solve it. Note that for x4 and x6 there is no leading one, hence it is a free variable. Since x4 and x6 is a free variable, we can represent it with a parameter. x4 we represent it with parameter t, for x6 we represent it with parameter f. Next, we can solve the system by using back substitution. After we have done back substitution, we get the answer that we want to find. The answer is for x1 equals to 25 minus x4. For x2 equals to x4 minus 5. x3 equals to 30 minus x6. x5 equals to 35 minus 66. And x7 equals to 25. For x4 and x6, it's a free variable. Beside Gaussian elimination method, we can also use Gauss-Jordan elimination method. For that method, we only need to zero out everything under and above the leading one, and we will get the same answer as given. And that's the end for our question. Before we end our video, I would like to thank you, Dr. Shamsatun, for giving us the opportunity to do a video for our assignment and for help us completing our assignment. So thank you for watching. Assalamualaikum.